Hello everyone, thanks for coming along to my session. For those that don't know me, my name is Phil Seamark. I work on the CAT team, what that used to be called the Power BI CAT team, but everyone knows now that Power BI is Fabric, so we automatically became the Fabric CAT team. What I do on the Fabric CAT team is I work as a DAX and data modeling specialist. So I tend to help very large organizations that just need extra help to make reports that are going to get used by a large number of people over very big data sets run as quickly as they can, because as you know, compute can be expensive when you're buying multiple capacities and large capacities, and organizations do want to make sure they get the best out of their investment, which is fair enough. So I get the opportunity to go on and look at interesting scenarios, and here is my opportunity to share what I've learned with people like yourselves. And I do often see patterns turn up, and one particular pattern that I quite often do get is, hey, we've got a slow report, it's got a very busy matrix visual on it, lots and lots of columns, lots and lots of rows, probably some slices and filters around it, and it does take a while to run, it's burning a lot of compute, and then I can sort of sit down, talk with them, and work out what's going on, and we can usually tune it quite a bit. And we're going to be doing some work today. So the actual title of the topic today is called Optimizing DAX Fusion. So the assumption is that you already have a reasonable grasp of DAX. You don't need to be a DAX expert, but we are going to be focusing on Fusion in particular. And if I jump to the agenda is quite short. If I change the slide, there we go, I'm in the right place. Cool. There's only 3 items. What is Fusion? Because it's probably important that we set that context. Then we're going to do this optimization exercise. We're going to peel through and just make subtle changes one after another, and we'll see what the impact has on the server timings, etc. And then we'll have a summary, some questions, and a quiz at the end, an exam. Mainly for the people at the back, just to see if they're actually awake and listening. No, there will be no exam or quiz. So let's set the scene. What is actually fusion? So we've got a couple of fusions. There is what we call regular fusion, and there is horizontal fusion. Now, for those of you who have used DAX Studio and run a query with the server timings on, you'll notice that in the corner box, you get some information back to say how many storage engine events took place. You see how long the query ran, but it also tells you how many storage engine events took place and how long they all took. And you can actually click on them individually to see what they are. And then there's the formula engine. Now, just a quick refresher, what is the storage engine and the formula engine? In my head, I like to think of baking a cake. So the formula engine is the kitchen, where you only have a single chef. Now, they're designed to put it all together and come up with the result. The storage engine is the task of going to get the data. So in a cake example, it would be something like going down to the local shop or supermarket. Now, what you don't want to do, you might have a very interesting and complex cake. You want to try and avoid making 200 trips to the store, going and getting just one item, going and getting the flour, then going back and getting the sugar, etc. What you're trying to do is minimize those trips. So what Fusion attempts to do is when you run your DAX query, the engine will generate a query plan, and that query plan will say, hey, I think for me to bake this cake, for me to get the numbers I need to render the visual, here's my plan. Here's how I'm going to approach it. And I'm going to go to the store 200 times. But actually, one of those trips is to just get a kg of sugar. And then another one of those trips is to get a kg of sugar. And another one's to get a kg of sugar. And they're the same thing. So rather than execute this round trip 3 times, why don't we be smart about the query plan, only go there once, and save time and effort, total duration, etc. Hopefully that makes sense. So what I'm going to do is just jump over and just explain the difference between regular fusion and horizontal fusion. Horizontal fusion is a more recent concept, and it's got some gaps in it that I've got to work around in a hack that we're going to explain. So what I'm going to do is jump over to DAX Studio, where I'm connected to a very simple Contoso database. And we're going to run some queries. Let's focus on regular fusion first. Okay, let's zoom right in. Cool. And I'm going to turn on server timings. Hopefully you've done this before, so you'll be familiar with that task. So what I'm doing in this very first query, there's going to be no fusion here, but I'm interested to see what the storage engine is going to do, what it's actually going to do on its trip to this supermarket. We're grouping by brand name, and we're running a measure called sales. Now, this sales measure is just sum of a column, sum of sales amount. It's not doing anything complicated. So when we run this, my expectation is I should only see one storage engine event. It should be pretty quick. And over here, for those of you who love SQL, we're at SQL bits, we can see, let's zoom in, what it's doing on that particular task. Now, the model that I'm using today, my fact table is in direct query. It doesn't need, all of this applies to direct query, import, and direct lake as well, so there's no difference there, but I've deliberately put my fact table into direct query so you can actually, we can see when we're hitting the expensive fact table. Because generally, tasks that talk to the dim tables are very fast. Usually you've got them in dual mode anyway, so I kind of ignore those. The ones we really want to optimize and make sure run very quickly are anything that talk to our fact table. Now, my fact tables are probably only a couple of 100,000 rows. Your ones might be billions of rows. So in this simple DAX query, we are grouping by brand name, and we're doing a sum of sales. So this is really nice. This is elegant. Here's our starting point. And if I was to run a second query, where the change is rather than do sales, we're going to group by the same brand name, we're now going to sum up the quantity column. And we're going to get exactly the same profile in the query plan. So only one storage event is needed, and that storage engine event is producing the same XM SQL, which is grouping by brand name, and now doing a sum of quantity. Okay, now if I change my query and say, I want to continue to group by brand name, but I want to actually get both metrics. I want to hit the fact table twice. Now, if you go back in time far enough, what would happen with Power BI or analysis services is the engine would say, well, I'm going to create two storage engine events, and they'll be exactly the same as the two storage engine events that we just had a look at. But regular fusion is going to kick in. So regular fusion, when it's working correctly, and you run a simple DAX query like that, it's going to be smart enough to, because it recognizes that everything from, join, group, and where down is exactly the same. We can merge them together, and we can be smart and say, let's put the two aggregate functions into the same query. We're grouping by brand name, and we can do one round trip. So we're sort of crafting, we're thinking ahead about what the ideal query would look like to be able to resolve our query. So that's regular fusion. That's been around for some time, and that's all about trying to combine the aggregate functions in the select part of your statement, so long as everything from the from clause down remains the same. And hopefully you're seeing that. Horizontal fusion. Okay. Control and paste. What we're doing here now is a very similar query. We're grouping by brand name to keep it simple. But say I want to get two columns, one that shows me sales for red products and one that shows sales for blue products. This could be, periods or all sorts of different things. And my filter is to say, all right, let's calculate sales, but apply a filter on line 5 so that when we calculate the sum of sales here, it'll only look at colors that are red. It'll help filter the rows, etc. And we've got the equivalent for the sum of quantity over blue. So we run the query. And this is horizontal fusion kicking in. I probably don't have enough screen real estate to show both. Horizontal fusion tends to pop up in the where clause now. Regular fusion has taken place because it's been smart enough to recognize, well, we're going to the same fact table that has both the sales amount column and the quantity column, so let's merge those together in this select part of the statement. But what's happened down here with horizontal fusion is it's added into the where clause an in statement. So we're filtering the fact table, or the dimension table that filters the fact table, to say we're only interested in blue and red. Don't give us any extra rows that we don't need, like yellow, orange, green, etc. And again, previously, what would happen prior to horizontal fusion kicking in is the query plan would go, no, I'm going to just make 2 round trips. And they're probably going to be the same amount of time, so your query is going to take twice as long and use twice as much compute, potentially. But not a lot of situations, well, that doesn't cover every single base. So what I'm going to do is actually break fusion here. So I'm going to paste in a query. I'll scroll this back a little bit. Hopefully you can see. So now what this query does is on line 6, I've put this additional criteria on the blue calculation line. Now here, everything from the from clause down is not necessarily the same because we've got this extra criteria that we need to apply. So we can't just create a simple in clause in the where statement so easily. So what's going to happen now when I try and run this query is I should see 2 storage engine scans. We'll have one storage engine scan that's handling the red calculation, and if I click on here, we'll see sum of sales amount, where color is blue and class name is regular. So this top storage engine event is handling row 6. And then if I click down here, we can see the XM SQL that is being used to get what we need for the red. And it's just a simple where clause. But we can't fuse those together because the where clauses are just too different. So it gives up, does what it's always done. And this might seem okay in a very small data set on a local machine. But as I said, when you're working in high concurrency situations on very large databases, here's an opportunity to optimize. Now, there is a little bit of a crazy workaround. I shouldn't say crazy, actually, that helps you get that exact query down to one storage engine event. And I'm going to paste it in. Okay, so my actual query itself now, I'm doing more things. We're grouping by brand name. That hasn't changed. I've got my classic calculate sales for red, and I'm doing a calculate sales for blue, but where class name is regular, and I've actually put in an extra one. I'm making it do extra work. Now, if you could pause here and think, if I was only allowed one trip to the storage engine, what would be the ideal shape of that query that doesn't give me any more rows than I need to be able to then produce the results? So I think what I need, if I was to just start writing T-SQL, I would say, I need to get sum of sales and sum of quantity. I want to group by brand name, but I also want to group by color name and class name. Even though this row at line 43 isn't necessarily using class name, I can derive the information I need. I can find all of the rows that belong to red and go and aggregate them up and still arrive at the right result. But if I was to run this query like this, without my overrides, I'm seeing 3 scans. There's one for each of the rows that are in there. So what I've done is I've overwritten the measures up here using an iterator pattern. Now what this iterator pattern does is it's smart about what gets pushed to the storage engine and what gets held back to the formula engine. It's not that intuitive, but what I'm essentially saying here is I'm going to perform a SumX iterator, give me a T-SQL result set that is grouped by color name, it's grouped by class name, and it actually is also grouped by brand name because that's baked down in the summarized columns and the query itself. So it's going to actually create that perfect grain that I need, but it's going to give me for everything. It's going to get for every permutation of colors, every permutation of class names, and every permutation of brand names. So it is going to be a reasonably big table. But once I've got that, I can use this pattern to use the formula engine to now start filtering down. So I have a couple of variables that figure out, based on the cell, what my filter context is. So I store in a couple of variables, whether I'm trying to find the details for red or blue or yellow, for example. But I go and get the entire intermediary table. And then once I've got that back, I do post-processing here by applying a filter onto that intermediary table that we get back, relevant for the cell in the result set that we actually need. Now, you can nest, there's more complex versions of this. And this is me overriding the sales calculation. If I scroll down a little bit more to my quantity measure, I've got exactly the same pattern. So everything up to here is exactly the same in the other one, where the SumX is controlling line 27, 28, 29, are controlling what's getting tasked to the storage engine, and then lines 30, 31 down to here is applying that post-processing filtering in the formula engine to be able to do that result. So will this work? I mean, and you do have to make sure it matches. What's really important to help Fusion work is to make sure things like the signature profile in this parameter is consistent across the measures you use it. So let's give it a test run and see how it works. So exactly the same query now. I'm going to ignore the scan events because A, they don't take any time. They're just dimension lookups. If we actually look at some of these individual ones, it's just give me a list of class names and color names from my dual table. There's no actual aggregation going on, no sums in any of lines 3, 5, 7, 9 down to 17. The only one I care about, and this is why I put my model in direct query mode, is where I have gone out to direct query, the SQL statement. So let's look at that SQL statement. This is a fairly beautiful statement. It is grouping by brand name, grouping by class name, grouping by color name, summing, and regular fusion's also kicking in, over the sales amount and quantity, etc. But there's no where clause. So the number of rows that come back, if I actually copy this over to, say, my Visual Studio and do a new query, paste that in and run it, how many rows? It's giving me 294 rows. This is a very tiny data set, so I'm not too worried about that, but there are actually ways that I'm going to show you in the proper exercise how you can craft that. It's artistic. It makes me happy. So hopefully that gives you the concept of what regular fusion is and horizontal fusion is, and what we're trying to do is take advantage of those. So now we're going to do our exercise. So imagine a colleague comes to you and says, I've built this Power BI report, I've watched all the Guy and Cube videos, I've followed all the best practices, and it still runs slow. Can you help me? Sure, no problem. So here's what the my attempt at a report looks like. It's not very pretty. I'm using an old logo apparently, but it's a very common pattern. And actually, I was collecting them for a while so I could actually show PMs that. You'll be surprised how many orgs actually have this a matrix at the bottom with slices at the top and lots and lots of different types of calculations. And this is a really busy calculation. There's a lot going on here. I've got the ability to select a month. I can slice by brand name because that's what we've been doing. I've got a dynamic period comparison, so I can actually choose whether I want to do my comparison metric with the previous month or the previous year to get interesting. I've also got a filter as a measure off the side in the filter panel saying just only show me the top 5 stores, and that's usually something that gives the engine a lot extra work to go. And I have 5 metrics. You don't see them because they're off to the side. We've got sales, quantity, transactions, and a couple of other ones as well. So there's quite a lot of work going on. So if we pause here and just again imagine looking at this here. If we had one chance to get the data and get no more rows than we need, no less, that we could produce every single number that you could see here, what would that query look like, after we sort of play with horizontal fusion, regular fusion, etc. And that's what we're going to try and get to. Okay, so what do I say? Yeah, busy matrix, super slow, 5 metrics with time intelligence. I'm using calculation groups, group by store. The user can do select the month, yada, yada, yada. I've all done this. And yeah, it's bright red at the bottom. I'm using a measure as a filter. That can be a real performance killer. Normally it's just try and get rid of it, bake the code into your measure, but I've kept it. I'm not changing that. As I said, my model's quite slow. So it is star schema. I've got nice dim tables, and my starting point doesn't touch DAX at all. I have deliberately done some bad things in here. And you'll see in the server timings, it was taking 21 seconds of actual elapsed chronological calendar time and over 100 seconds of storage engine time minutes, and it's doing 337 calls to my supermarket. It's a lot of work. And imagine 2 or 3 people trying to access this report at the same time. Now, the obvious thing to do here is fix the relationships, because I've got weak relationships here. And this is the only time I'm allowed on stage to talk about relationships. I've got BiDi turned on everywhere. I've got, in fact, that's it. I thought it was many-to-many, but which isn't bad. I've got it in my optimized solution. I am using many-to-many. It can be quite efficient. We'll get to that. But I've also got my dim tables in import mode and my fact table in direct query mode. Now that means they're in completely different islands. So straight away, all your calculations that involve columns in both sides, like grouping by brand, summing up by a column in the fact table, is going to have to do 2 trips. One to the import dimension table to go and look up some values, and then a second one, it's going to have to wait until it gets those values back. It's going to construct a second query always to the fact table with a big long where clause saying, oh yeah, where brand name or color is in yellow and red and whatever. So the very first thing you do is A, fix the relationships, but B, make sure your dim tables are in dual if you're using a direct query fact table. And that brings them into the same data island and allows queries that make sense to use the import version of the dim, like give me the unique value so I can populate a drop down of a slicer. You know, I'm not crossing into I'm not touching the fact table. So I'd use the import version in that case, but if I was doing group by brand sum sales amount, maybe I'll be able to push a query that can, a piece of SQL that can do it in one step, like what we've just been playing with. So, okay. So I've got my bad report before localhost. Okay, so we will turn on the optimization performance analyzer so I can capture the DAX and take it to DAX Studio, start recording, and my slow report. And this might take actually 20 seconds. Hopefully it's not too bad, because otherwise I might have to go back into my joke recipe. Speaking of chefs, I quite like salads, but everyone says they're too dry, and I think, oh yeah, no, that needs a dressing. How are we going here? 23 seconds. That felt like 50 seconds, didn't it? Matrix, copy query, and you can see this is the matrix that we showed you in the slide deck, etc. And over here I've got a top 5 by store name. That's awful. If I go back to here, DAX Studio, paste in this DAX, and I'm going to run it against my before model. My before model, if I connect, is exactly the one I just showed to you. So the fact table's in a different island and the relationships are set as BI DAX. Will give us the correct result. If I get server timings on, waiting for server timings. Oh, yeah, I clicked the wrong thing. Good spotting. And we'll turn that one on. We'll get a query plan too. I'm slowly starting to learn how to read query plans. I don't know if that's a good thing, but it is sinking in after years and years.
Question while it's running.
Yeah.
So I've noticed with the direct query and the SQL that it generates, even if I'm going into Postgres, it still generates that T-SQL in DAX Studio.
Yes.
Is it just something it does no matter what?
Yeah, and actually the version we saw, so the question is when you're using DAX Studio and you click on say a SQL line like this, for example, and you've got the XM SQL version over here, will it do it for Postgres? Yes, it will, but there's 2 versions of this code. This version here is actually the summarized version, which coincidentally does work when you're working with, say, a SQL database. If you're using Postgres, what you want is to right-click in the space and just click on Raw Query, and what that will give you is the dialect of the code that did get sent to the Postgres database, which might have just subtly different logic and syntax. And look at it, this is horrible. So I've run my query. This is the first one. 14 seconds, not so bad. 337 trips to the supermarket. Now, some of these supermarkets were just to the corner dairy, those import dimensions which were fast. But if I sort by duration descending, all the SQL ones, I'm scanning down, scanning down, scanning down. There's a lot. They're reasonably quick, but you know these are very long SQL statements with very long where clauses, and it is pretty much because of the data island thing. So if I don't change the DAX at all, and what I do is I connect now to a version of the model where the only difference is I've fixed the relationships and put the dim tables in dual. I haven't touched the DAX yet. So if we connect to my after and turn on server timings, waiting for the trace to start, and it's going, we run this, I'm not going to spend time jumping back and forth between the results, but just trust me, it does produce the same numbers, same subtotals and totals, etc. And where were we at? We were 14 seconds and 337 storage engine events. So we're now down to 8 seconds without even touching the DAX, and 124 seconds. The SQL, if I sort by duration, for some reason I can't sort by subclass, but I can sort by duration. There's probably not as many. They're never that long, but if I sort by query, there's still duplication. So Fusion's not really kicking in much. There's things blocking Fusion. Now, one of the things I am using in this model is a calculation group. And for Fusion, there are certain optimizations that won't attempt to work if calculation group is in play. Now, we're using a calculation group in this model to handle the ability to make 5 metrics. Now, you can still do that in an old-fashioned way using a disconnected table with as many rows as there are calculation items. In fact, if I jump back to my after and see if I can remember which table it's in, I have a matrix measures table. Yeah, so this is not the calculation group. This is just a 5-row, 3-column disconnected table that is purely used to be able to drop into the top of the matrix to make sure I have a sales column and a quantity column and a transaction column, etc., and then have the measures to do just the base calculation plus the period comparison plus the diff. So if I go to Power BI and jump to version B, which is that change. Okay, and if I turn on my performance analyzer to capture it. So the only difference here, and I'm going to double check my notes between this version, is there's no DAX, that's the last one. Cool. We're using a measure table instead of a calc group. Still using the classic date table, and we're not using that SumX trip yet. That iterated trick that I showed you, that workaround at the start. Oh, I should have hit the refresh the visual. Here we go, to capture this DAX. Pretty quick, so it's obviously going a bit faster. Hey, there might be some caching. If we get it over to DAX Studio and we have the clear cache on, we'll see what's really going on. So if I Control A and Control V that in, run it now. So we're now down to 13 queries. In fact, there's only 5, I think, SQL queries. There is duplication, so there's opportunity still to do some more Fusion, but it's looking pretty good. So the first one, the top row is grouped by continent name and store name. The second one is grouped by continent name. The third one is by continent name and store name. A couple of those could be fused together. Then we're grouping by nothing at all, so that's probably a row total. So, but it's another round trip that's doing to run the calculation that it thinks it needs for the not grouped by anything. And it's all taking time. This might not seem so bad. You might think, hey, we're now under a second. That's pretty good. But again, if you've got a lot of users hitting this, it's going to take up time. Cool. Okay. So that's just simply, that only change there is to remove the calc group. And you saw how much Fusion has kicked in, because we've taken about 117 storage engine queries, which maybe 50 were SQL, down to just 5 SQL queries. So they're just simply replacing calculation groups, unfortunately, allows quite a few optimizations to kick in. And you probably could stop there if you wanted to in some situations. But I just want to see how far I can push this. So what's my next change? I'm going to introduce the SumX pattern into the core measure, because I want to see these go away. So what does that look like? So if I jump to my SumX pattern version, what I have over here is, in my version C, I have a core measure. Which does current month C. So I have a measure that just goes and figures out measure core C here. It figures out from the disconnected measure table whether you're trying to do something with sales, quantity, transactions, or something else. It's storing in variables essentially what the filter context is for the cell in the matrix that is really executing this. And I've got 5 blocks of code here, one called measure 1. I'm not that good at naming things. I have pretty much what looks like exactly the same measure 2, measure 3, measure 4, measure 5. The only difference between them is my measure 1 variable does a call sales. Otherwise, it's exactly the same. If I scroll down a little bit, my measure 2 variable, all I'm doing is just dropping quantity in here. And then coming down here. But the important part is I'm using that pattern that we talked about, because if I have a look at the report page and I think what would that perfect intermediary result look like, I would want it to be grouped by store and grouped by first day of month. And see here we're even nesting these sum x's, and the reason why you would need to nest them in this case using this pattern is because I've got multiple dimension tables kicking in, and it works perfectly. It looks ugly, it looks terrible, but it's not too, it works perfectly in terms of allowing Fusion to kick in. And of course, with this measure 3 that we're zoomed in on here right now, identical to measure 2 and 1 apart from this calculation. And then somewhere down the bottom, there's a switch statement to say, okay, well, we ripped out the calculation group, so do we want to return the sales quantity, transaction returns, etc.? And it's smart enough to know with this pattern not to execute unnecessary stuff. It will return just transactions and not the others in this case, because I've done things like put the code into a variable. I'm not using an else branch. Some of these things are, oh, I sounded Australian then. The else branch can cause a problem. That's just subtle little things. So this is a really important pattern, but I only need to do this once, and then I can wrap this measure with a few sort of helper type things that say, okay, let's, for the current month, I want to calculate that big block of code that we just said as is, but do it for sales. For example, that must be selected value, default sales. Otherwise, it's coming from the context of the column that we've dropped into the result, the header. For the comparison month, we're doing exactly the same, but we're just doing this date add, and we're going to jump in blocks of months, and we're going to jump as many blocks of months as we need to from an offset that's coming from somewhere, and I'll get to that. And then, of course, we've got a diff measure which actually calls both measures and does a little comparison here to figure out whether we're 15% up or 46% up. Isn't that fantastic? So what does this look like in server timings? If we grab this code for matrix C, copy query, I believe this has run. We'll know from the server timings, because I'm trying to get down to one call. And if I click on here, Control-All, Control-V, run this. And remember the last one only took about a second. It was 700 milliseconds or something. Well, this is taking longer. Not long enough for me to go back into that horrible bag of jokes, but we're up to 12, 13, or maybe I might need to. Query is running. It doesn't normally run this long, but the good news is there is only one SQL event. So we're making progress in terms of the number of trips to the storage engine, but these numbers look terrible compared to what we just had. And if I scroll down, look, all the others are scans. They're not taking any time. The whole time was spent going to get the query. Now, it doesn't normally take this long. Normally, it does take only about a couple of seconds. And but if you're familiar with the timeline feature in DAX Studio, this dark blue block here is showing us in the overall scheme of things how long did I spend executing the query, but they're spending just as much time afterwards doing that post-processing. So that smart, clever thing that I told you to do is still costing us another 10 seconds. I'm just going to run it again out of curiosity because it doesn't normally take that slow. And we're going to look at the XM SQL because we're getting there. We've got one more step to do. And I'm getting the 15-minute reminder, and I want to have time for questions. Okay, it's still taking 20 seconds. Okay, I'm just going to All right, let's have a look at this XM SQL. What's it doing? Is this in the perfect shape that we could possibly want it? Lots of regular fusion happening up here. We're doing sums of return quantities, return amounts, count stars and sales quantity, etc. We're grouping by store key, first date of the month, and continent name. This is perfect. This is actually looking really good. And they're all in a join, so that's really important. I've got my my assume referential integrity settings turned on for my DQ. And we've got a where clause, excuse me, because there's a slicer on the desktop set to Contoso. Now, the reason why this took so long is because the Cartesian join of every unique possible value in the continent name column, the first name of month column, and the store key column is starting to blow out. If I take this query and run it over against my database, so I don't know why it took 10 seconds for me there and it's only taking a fraction of a second here. I can see that there's 10,000 rows. Now this is still quite tiny, and it did actually return quite quick. I might be still pointing to somewhere weird in my model, but that's not important. Now at the moment, I'm grouping by every single possible month. And if I've got 2 or 3 years worth of dates and values, that's quite a lot. Now in my report, I only ever want to care about 3 months because I'm asking the users to say, you pick the month, you pick May 2008, excuse me, in this case. Now, if they pick a month, I only ever care about, at max, 3 months. I want that month, I want the previous month that belongs to it, and I want the same month from the previous year. I don't actually need all this other stuff. So I really need a way to influence the where clause to say, don't get every single possible month, just get the 3 I care about based on what the matrix actually needs. And that should hopefully speed us up because it should mean the intermediary table that gets back isn't 10,000 rows, which takes longer to post-process because once it's in the formula engine, it has to do a lot of single-threaded back and forward, which is slow, can be slow. So how do we get the where clause? And this is where the many-to-many relationship does come in. I'm going to show you it here in the after. So I blog about this on my website. There's a pattern called, I forget it now actually, time intelligence something. But here I've got a TI table. And in this TI table, I have a row for every month. In fact, I actually have 3 rows for every month. So I sort of pick May 2008, and I also have the rows for May 2008 that are relevant to that because I want to use them in the where clause. Because remember in the report page, you know, here's that slicer I was talking about. And at the moment, the slicer is just over the month column in the date table. What I want to do is jump over to this time intelligence table that I'm adding on, and let's have a look at what that might look like. So if I pick a given month, say April, May 2008, because I know that's what we're using in the calculation, here we go. So I have got every copy of every possible months, and then for each month, I have what months make sense. And I also include the offset as well, so that helps me in my calculation and my date add to go, all right, when I do need the previous month, just go -1. When I need the previous one from 12 months ago, I can, etc., use that. It's not going to be a particularly large table, only needs a couple of columns. It's going to be very low cardinality. And what I need to do, and this is the really important step, is I replace the slicer to now use this column. So this column here is going to give me the unique values, and it'll just look identical. But when I make a selection on that slicer now, what's going to happen is filtering is going to apply here. That will then go in through my many-to-many relationship to my calendar table, and then that'll go down and filter to the relevant rows in my fact table. Now you do hear, okay, avoid many-to-many, it's just an automatic bad thing. The true answer for that is you just have to be very careful with cardinality. Because I know ahead of time in this report, the slicer can only ever have one value selected. You know, maybe I can lock it down to that. Then this table that I've got highlighted in red can never have more than 3 rows. So the the join, the hash join, the lookup is going to be cheap. It's not going to try and join a million unique values over here to a million unique values in there. That's going to be where the problems around many-to-many give you a lot more compute. So in this case, it's perfectly fine. And in fact, this is going to be the trick that allows me to inject the where clause, because when you have physical table relationships involved, they start turning up in the from and the where clause. So let's have a look to see what this looks like. I'll clear the context and we're going to jump to D. So the only difference between C and D is using now the TI table, fusing of measures. Yep, all right. So we'll click on that. Pretty quick. Capture the DAX. Jump back to DAX Studio. Control-All, Control-Paste. I don't know if that worked because I can't see it. Control Delete, Control Paste. Cool. And now we will run it. Oh, this is not helpful. Honestly, I did this earlier today and it was a second. Okay, just trust me, this is normally a second. This is running, something just weird is a little bit happening. But certainly that post-processing has gone away. It still seems to be taking about 10 seconds to do the round trip to the server. This does normally take about a second. It is slightly slower than the other versions, but we've got one SQL statement here. If I sort by duration, I only have one SQL statement. It's the same select profile as our last example in terms of regular fusion, etc., same grouping. But if we scroll down, we're going to see a work of art. My where clause now has got that in clause that has been injected because of that many-to-many relationship put in. Now, if I copy this code over to my query, replace it and run it, I think we had 10,000 rows previously. And it was pretty quick. This is down to 800 rows, and you saw it was, well, this is telling me 2 seconds. And I mean, this might not seem worthwhile when it's such a small data set, probably isn't worthwhile, but it really does pay dividends when your data sets are much larger, and thinking about what can I do in the model to craft that one shot at the database engine. And I have had many situations where I'm with customers, we load up the page, first thing I do across all the visuals is say, well, how many calls are you making to your fact tables? And let's look at every single one of them. How are they grouping? What are they aggregating? And let's look for patterns and see what we can merge together. And I did have one escalation where I think it was at 140. They were using a genuine direct query data source. They were really opposed to the idea of duplicating into the model. Fair enough, that was their choice. But their reports were really slow. And I think we got it down to, they had 4 visuals on the page and we got 4 storage engine scans, and they were delighted. They probably found some other things to be grumpy about, but and that's the exercise. So we went through version B, we replaced the calc group with the measure table. That was straightforward. We introduced the X pattern to reduce the storage engine calls down to 1, and then we finally, we improved that storage engine call. And this all was relevant for import too. The fact that I'm doing it on DQ is just making it easy to demonstrate and run the queries and show stuff. It is the same approach, the same pattern. So in summary, what are your takeaways? And I really don't expect you to remember all this. If anything, it's just letting you know that if you do need to do optimization, there are extra things that you can get into, there are extra dials, and just be aware that you can improve it. Definitely check your relationships and storage modes, make sure you're using few data islands. Just hopefully you do understand what this term regular and horizontal fusion are. The iterator pattern, it's ugly, but it works. So what you do end up with is probably measures that are dedicated for that matrix. I wouldn't necessarily do this for every single measure and every single visual. It's just really these slow matrix. And quite often, to be honest, card visuals and KPI visuals should be pretty snappy anyway, especially if you're following best practice. Consider that time intelligence table approach with the many-to-many. I have a note to myself about dynamic format strings that probably made sense at one point. It escapes me now. And then definitely the switch else and variable pattern can help with fusion as well. So if you are using switch, avoid switch true. Use switch a specific value, and then in the return branches, return a variable that's been pre-calculated. Seems a bit counterintuitive, but it works. It works in it allowing fusion to kick in. Both will still produce probably the correct result, but that can help. So takeaway, as I said, should you apply all these techniques all the time? Probably not. Performance versus flexibility. You're creating more complex code. It's harder to manage. It's very hard to explain to someone. I'm lucky that I get to do DAX all the time, so I can at least look at this and remember it. But most people, if they do a little bit of DAX, they don't do it for a few weeks, they come back and they've forgotten it again. So it does introduce problems with code maintenance. But if your goal is just out and out performance, it's possible. And as I said, it works for Direct Lake too. So I think we've got a few minutes for questions. Has someone got a mic? I have actually done this before and had no questions. And I don't know if that's a good thing or a bad thing. But otherwise, I'm doing another session at noon on Direct Lake in room 3, I think. So someone's got a hand up here. Yeah. I don't know if someone's going to come with you with a mic, or do you want to just shout it out? I'll repeat the question. Could you replace the nested sum-x with summarize? No, it has to be an x iterator, but it could be max x, it could be min x, it could be concatenate x. I don't know why you do that, but it has to be an iterator because the iterator does have a special relationship with the storage engine. So definitely use an iterator if you want to apply this pattern that I've shared. No, I'd have to check. I don't think so. The question was, could you apply the workaround pattern using summarize in place of sum-x? And my answer is, I don't think so. I think you need to use an iterator. So one of the many sum-x, min-x, max-x, concatenate-x, there's a few of them. So down here. Okay, so I think the question is, you've got some reports that use both calculation groups and field parameters. You know, are field parameters slow? Field parameters can actually be quite fast. Field parameters are an interesting property. They're not really analysis services. The engine is not even aware of field parameters. They don't know it exists. What happens with field parameters is it's more a Power BI construct in the way it generates the DAX that then gets sent to the engine. So what a field parameter will do is it'll craft the summarized columns and actually add in the group by columns. So generally they're pretty quick. So I have had some recent customers that have been heavily using calculation groups and they're now using field parameters to speed up and perform the same functionality, and they're very happy with that. Wouldn't necessarily be every single case, but and I don't think there's a perfect 100% overlap, but I think you're less likely to have the fusion problems with field parameters in the nature of the way it constructs the DAX before it gets to the engine. Excuse me. There's questions over here. There was one. No, sorry, yep.
You mentioned the iterator pattern, X pattern, time intelligence pattern.
Yes.
Anywhere?
Yes, I do. So I mentioned a couple of patterns. My blog site is dax.tips, dax.tips. I don't post a huge amount here, but if you go down into categories such as time intelligence, then you will find them. If I can't even find time intelligence, it's probably there. Time intelligence is over 2 rows. So there will be some articles here. Row-based time intelligence, this is exactly the one that I was talking about, and I think I wrote this probably 4 years ago, 2020. Yikes, and it's still relevant, still works. So, last question. So the question is, I've got small model, I'm not too worried about the storage engine side of things, tips on the formula engine. Try and, as I said, the more you can give to the storage engine, the better, even in those small situations, because the storage engine is multi-threaded. You can actually send all your kids out to the store at the same time and have as many kids as you can put up with. But there's only one chef, there's only one formula engine. So in a lot of ways, pushing stuff into the storage engine, getting it to do more of the work, leave the chef as little work to do as possible just to assemble the cake, the better. Tips, probably depends. I don't have enough time, I'm afraid. But if you've got a 100 core machine on your P1, the fact that you can multi-thread out all that storage engine stuff can be quite good. And but there's also equally an argument to say, well, emphasizing the work in the formula engine won't tie up the machine. But yeah, okay, depends. Anyway, thank you all for coming today. Hopefully you learned something. As I said, one takeaway is you can probably do more interesting advanced stuff if you want. The recording, you can go back and watch, or reach out to me on Twitter, LinkedIn. More than happy to take calls because it's quite a niche topic. I'm not going to get overwhelmed. But otherwise, thank you for coming. Enjoy the rest of your conference, and I'll be here for a couple of minutes just for up. And the organisers remind me to say, don't forget to do feedback. So.